In this video, we'll go over Le Chatelier's principle with gases. So with gases, it's a little bit tricky because when you shift the pressure and shifting the concentrations, it's sort of counterintuitive. Actually, that's what Le Chatelier's is. It's basically whatever is done to the equilibrium, it's going to respond counter. With increase or decreasing of pressure, we have to go sort of counterintuitive to how the reaction will react or proceed. So increasing the total pressure on the system, notice these two are gases. 2 moles of this gas goes to 1 mole of that gas. Increasing the total pressure on the system by decreasing the volume. So you have to ask yourself this question. What is the opposite of increasing the total pressure? Remember, Le Chatelier's principle is all about doing the opposite. So they increase the pressure. How will the reaction respond? It will respond by decreasing the pressure. Now, which side has decreased pressure? Is it the side that has 2 moles or is it the side that has 1 mole? Well, the side that has decreased pressure exerts less pressure is the side that has less number of moles, right? So the opposite of increasing the pressure is the reaction will go to the side with decreased pressure. Decreased pressure happens when you have less number of moles. We predict that for part A, the reaction will shift towards the product side. What about part B? Adding gaseous I2 to the reaction mixture. So what's the opposite of adding? It's subtracting. So when we add I2, the reaction will proceed to subtract I2. That would mean it would go to the left towards the reactant side. And finally, decreasing the temperature at constant volume. So decreasing the temperature would actually mean you decrease the pressure, right? This actually is Charles' law. Increasing the pressure happens when you increase temperature, right? Increase the temperature, the gas molecules will have more kinetic energy, more collisions, and henceforth you'll have greater collision frequency, which means more pressure. So that's in response to a pressure-temperature relationship. So here, decreasing the temperature automatically implies you decrease the pressure. So what's the opposite of decreasing the pressure? The opposite of decreasing the pressure, how this reaction will respond, is go to the side that has an increase in pressure. So the side that has an increase in pressure is the side that has 2 moles or 1 mole. Well, the side that has more exertion of pressure is the side with 2 moles. So here the answer to part C is that it will shift to the left, to the reactant side. Once again, decreasing the temperature means you'll decrease the pressure. The reaction will counterbalance that by increasing pressure. So the side that has increased pressure is the reactant side because 2 moles exerts more pressure than 1 mole.